This is problem 133 of Neetcode 150, meeting rooms. This is definitely an easy problem. You'll see we won't even need the whiteboard to understand the logic first. It is quite intuitive. So what we're going to be given is basically tuples, and in each tuples you have the time at which a class starts and the time at which a class ends. Okay, and we want to know if we can take all these classes. And now we can see the first example. We have a class that starts at 0 and goes up to 30. We have a class that starts at 5 and go up to 10. Can we take both? Well, DC not, right? Because we will have to leave in the middle of this class, go take this one, and I think you get the concept. So what I will do is that I will basically sort them. We are allowed to sort because we are being told that we should aim for a solution with big O of n log n time complexity, which is exactly the time complexity of a sorting operation. So I will sort them by the first index, and then I will just say, like, for the first value, I will set the end time to be like 30, and then I will go for all the other classes, and I will just check if the start time uh, is before the end time of the previous one. Will return false. If it is after, like for example, if we don't take a look at the 0 and the 30 and we just have 5, 10, and 15, 20, right? So initially what we will have in this situation, we will have an end time at 10, and what I will do, what we will do if we have 15 and 20, we'll just basically update the ending time to be 20, right, at this point, so that for the next class, let's say this class was basically 25 to 30, we will know that the ending time of our previous class, or like the latest ending time of all the classes that you have to take before is 20. So by having a class that starts at 25, we're good, and now we will update the end time to be 30. So let's go ahead and solve this. One thing that might be a bit confusing is that instead of using, for example, intervals 0 like that, or intervals 1 to get the end time, we're just going to use intervals that start as they specified here. And actually, we don't really need that. We're going to use intervals that start and intervals that end to get the ending time. Okay, so that's it. It's not super complicated. So what we will initially do is that we will basically sort the intervals, and we can't just say this. Okay, we're gonna have to say that we want to start with the first index, because each classes is stored inside a tuple inside, so we can't just say sort like that. So what we're gonna do is that we're just gonna specify them to start, like, for each index inside intervals. So for I, basically, I want to store them by the starting index, so like that. But in Python, I actually can't do that. I need to say key equal lambda I, so that I know that I'm gonna use this specific lambda is just telling it that we are gonna sort each character, and for each character inside the interval upon which we're using the sort function, we want to sort them by the I equals start. So this is probably the most challenging part of this problem. Once this is done, we can we can create an ending index that will initially be equal to intervals at the index 0. So like we take the first intervals once they are stored, and I want to take the ending. So I want to take the end time of the first class. One thing I forgot to do is that if the len of intervals, if this is equal, well, if this is smaller or equal, well, it can't really be smaller than, but let's just say that to be safe. So if this is smaller or equal to 0, we're going to return true. This means that we have actually no classes at all. And let me just put an equal instead of a smaller or equal to. So if we have no classes, which is actually in this case I got myself caught upon on the first try of this problem. If we have no classes, well, it's fine because we can take no classes. There won't be any conflict in our schedule. All right, so now we have the end time of the first class. All the classes are stored in the starting time. So what I will say is that I will just say basically for the starting time and the ending time of each classes in intervals. So for start and in intervals. And I actually want to skip the first class as I already know what its end time is, and we know that its start time won't conflict with any classes as it is the first one we're taking. And what I will say is basically if the starting time, so if start, if this is smaller than the current ending time, well then we have a problem. So if the starting time is less than the end, we're gonna return false right away. Otherwise, it means that the starting time is greater or equal, so it's later or at the same time at. And actually, if a class ends at, let's say, 30 minutes and another class starts at 30 minutes, there won't be any problem. So, I mean, the only problem is if a class actually starts before another one ends. But if a class ends while the other one starts, that's not a problem. So this is what we're going to contain here in our else statement. In our else statement, if the classes don't clashes with one another, we're just going to update um, the end variable to be equal to the end. So um, actually, I can't say for start end because I have a tuple. So what I will say, I will just say for I in intervals, and I will just call them like this. So for I that starts, if the I that starts is smaller than the end, we return false. Otherwise, the n is going to be I that n. Um, I don't know why they made it a tuple. Honestly, it's not super convenient. It would have been better if it was just straight array, but I mean, it's fine. Okay. So now at the end, if we never return false, we're just going to return true. Because if we never return false, it means that every time the start time of the class is equal or later than the previous ending time. So this is not going to be a problem. So we're just going to update the end time. And at the end of this loop, we're going to return true. So let's test this out. This is working. And in sort of in terms of space complexity, well, depending on our sorting algorithm, we might have a big of n time complexity, space complexity, pardon me. But since we're not storing that in our code, we can assume that we have a big of 1. And for the time complexity, well, the most expensive operation is going to be the sorting here, which is a big O of n log n. So the rest actually it's linear time, right? We're going once through every single courses. So it's going to be big of n, but since we have a big of n log n here, it's going to dominate. So this is going to be your time complexity. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.